Okay, so two things we'll talk about today, function notation and linear equalities, just so that we're comfortable with function notation. Function notation is when we replace y with something else. We'll call it a function of some variable. Usually we use f of x, but it can be anything. We could have y being g of r. So we'll use r's in our equation. In this situation here, we'll use x's. Typically, though, it is f of x. And typically an equation is given to us like this. F of x is equal to 2x plus 3. And you have different types of questions using this notation. And it's important to realize that, x is here. If I replace x with a 2, well, in my equation, I'm going to replace x with a 2. And I get f of 2 is 7. Now, this is like understanding that we have a 0.27, but it's not really what we're asking for. Asking for what is f of 2? F of 2 is 7. If f of x is 9, what is x? Well, f of x is 2x plus 3. We're using the same equation. If f of x is 9, what I can do is take that 9, that f of x is equal to, this is f of x, I can replace f of x with 9. And then find x. Okay? If f of x is greater than negative 3, what is x? Well, again, we're still going to be using, in this situation, the equation f of x is equal to 2x plus 3. But in this situation, I'm going to replace this f of x with what f of x is equal to. F of x is equal to 2x plus 3. So I can replace that with an entire expression of x's. And solve. I subtract 3 from negative 3, add negative 3, that turns into negative 6. I divide by 2, I get x is greater than negative 3. And I can plot on a one-dimensional plane values that are bigger than negative 3. If I have two equations like this, h and g, when is h less than g? Well, I can take what h is equal to, replace h with it. I can take what g is equal to and replace g with it, giving us something that is solvable. And in this situation, I'd probably keep the x's on the right side so they stay positive. I'm adding negative 3x to both sides. I get negative 2 is equal to 2x plus 8. I'll then subtract 8 from both sides. I get 2x is greater than negative 10. Divide by 2. I get x is greater than negative 5 when I read that from right to left. You can write it as x is greater than negative 5 that way. Either way, negative 5, open circle greater than. Okay? So, that's function notation. Another thing we need to be comfortable with is writing an equation of a line given a graph. We haven't really done that yet, but it's not too hard as long as we know how to write equations of lines given information. And I'm given information here. Okay? For this equation, for this graph, I'm given a y-intercept, which is what we consider our b. Okay, that's good information that I can get from the graph. The other thing that I can get, knowing that I have an x-intercept at negative 1 and a y-intercept of 2, is I can get the slope. I'm going up 2 and right 1 to travel from one point to the other. Knowing slope is rise over run, we know that the slope is 2 over 1. I have an equation y equals 2x plus 2. If I don't know what the y-intercept here, I can kind of take a guess, but we don't want to guess, okay? It might be at some decimal, some fractional value that we can't know for sure. What can I do? I could use rise over run again to find the slope. I'm going from 3 to 1 with my y values. Subtract those, it tells me I'm going down 2. I'm going to the right from negative 2 to 3, so that's a total of 5. My slope, rise over run, down 2 to the right 5. And then I could use either point in my point slope form. Y minus 1 equals negative 2/5, x minus 3. Okay, so we're good with that. But now let's move into linear inequalities, which is the kind of second half of this lesson. Okay? Y is greater than or equal to 2x plus 1. If I had a one-dimensional inequality like this, we know we have a one-dimensional axis, and we can use the point and we say, all my solutions are to the right of 2. But here I have 2 variables. I have 2 dimensions. So I have to look at a 2-dimensional axis. Now I'm just going to start with just graphing y equals 2x plus 1. And I can just say 1, apply a slope of up 2 over 1, or just plug in another value. Get 2 points, you create a line of solutions. Okay? Infinite amount of solutions. And let's just check to make sure that those solutions work with this inequality. So I can check like 0, 1. Does that work? Well, is 1 greater than or equal to 2 times 0 plus 1? I end up with 1 greater than or equal to 1. Yeah, that's correct. So that's a solution. So we should make sure we have a closed circle or the line going through that solution. Okay, I can check 1, 3. And do I get the same thing I do? But we're saying that y's can be bigger than 2x plus 1. Now, where are y's larger? Y's are bigger up here. Think about our y-axis. Large y's, when y's are positive and large, are up. Small y's, negative y's, are when y's are down. Well, I can pick like another point where my y's seem to be bigger. Like, let's pick this point 0, 6. I'm going to check this point 0, 6. Does 0, 6 work? Well, is 6 bigger than or equal to 2 times 0 plus 1? Is 6 bigger than or equal to 1? Yes. So that is a solution to this inequality. So I need a closed circle there. Let me check another point like negative 2, 3. Let me just check that point here. Does that work in my inequality? 3 is greater than or equal to 2 times negative 2 plus 1. Is 3 bigger than negative 4 plus 1? Negative 4 plus 1 is negative 3. Is 3 bigger than negative 3? Yeah, so that's a solution too. So I need a closed circle there. And if I checked here, I need a closed circle here. And if I checked here, I need a closed circle here, closed circle there, closed circle there. I need a lot of closed circles. Because all of these solutions, all these points are solutions. They will satisfy this inequality. But it's going to take me a long time to put a lot of dots down. So what would be a better thing to do instead of using a bunch of dots? Why don't we just shade? We use a line to represent an infinite amount of XY solutions for just an equality. Why don't we shade to show that, hey, not only does the line work in this situation, but all of these points will satisfy the inequality. So the shading represents the infinite amount of solutions at work. Shading is all XY solutions to the inequality. Okay, let's look at something like this when we have y is less than negative 2x plus 1. So it's a little bit different. I can plot the point 0, 1. I can apply the slope to get the point 1, negative 1. I have my line, but I'm going to hold off on that one, okay? Because let's check. Does the point 0, 1 work in this inequality? Notice it's just y is less than. Well, if I plug in 1, I get 1 is less than negative 2 times 0 plus 1. Is 1 less than 1? No, equal to 1. So it seems like I have a point that's very, very close to being correct and being able to work, but it doesn't work. So I can't put a closed circle there. No, this is wrong. I'm going to put an open circle, right? Because usually when we have a situation where we have x is greater than 1 on a two-dimensional plane, we use an open circle, right? So I'm going to put an open circle there because we're right there. We're almost there. And it would be the same thing here. I would use an open circle. at 1, -1. And if I kept looking at the line of solutions, I would have these open circles all on the line. But if I checked any point where my y's are less, where I have less y's in the negative range when I'm down, so like here, 0, -3. If I plugged in 0, -3, I'd have -3 is less than -2 times 0 plus 1. Is -3 less than 1? Yes, so this is a solution. This would be a solution. This would be a solution. This would be a solution. So I want a shade underneath it. Now we're not going to use open circles because this is annoying to draw. So what we actually use is a dotted line. A dotted line represents open circles, but we will shade to show where my actual solutions are. I will continue this video to get through the rest of the examples so that you are ready for your quiz next class. I would advise you to, at minimum, watch the remainder of this video.